Right. Hello, my name is Simon Vestergaard Laursen. I come from Gavdi, and I have the pleasure today to talk a little bit about well, plug and ask, as I call it, enabling AI context in CAP through the power of plugins and MCP. And I'm very excited to take you through this journey because it opens up a lot of opportunities, and especially something that can really help in the CAP workflow and also for custom applications going forward with CAP. I'm gonna be talking about briefly here in the beginning about model context protocol. I know that a lot of other people are already talking about it, both online, but also there is another session here at the Serverfest that is covering it a lot more in depth. So I encourage you to check that one out. But what I want to cover today is just the quick basics, what it is, why we should use it, and then I'm going to go into a little bit about how that was integrated into CAP and what the thoughts were behind that before we then actually go into the code where you can see how we go about implementing MCP into a CAP application. And of course, I'm going to be covering a little bit about some ways you can use it. So hopefully you'll get the full context here. So, but let's just start out with the quick basics here of what is model context protocol. And the quick way of actually going through it is just by saying, well, it is a unified protocol that we use to communicate with agents, AI agents, and a piece of data. It can also be used for providing context between different agents, so you have kind of a middleman approach. So if we go back to how things used to be before MCP got introduced, you would have your data, and then you would have your AI agent. And then for each agent you might have the different types of agent. There are many on the market at this point. Well, then you would need a custom integration between that data storage you had, be it a custom database or an existing system that you had. And for each of them, you have a custom integration where you would then need to do that on top of what you've already made. What MCP does is to basically just remove that part, remove the custom integration, and instead we can then, through the power of MCP and now also with the power of CAP, actually go in and just make a uniform communication between the data and the AI agent. And even the cooler part is we can use existing business applications in there. So what we then do in CAP is that we are the server and we provide the context that the client, the MCP client that is on the AI agent, can then translate and understand and use for certain actions, certain context clues, and also just to give info to the end user. What is very important to understand when you look into MCP is that it's divided into three main subject areas. The resources, which is something that it can read, and it can actually be an OData API. It can be, which it is in this case, it can also be files if you create an MCP server that is running locally on your machine. But basically, it's a resource that it can keep reading from to get context clues about what is active in your system. The other part is the tools. That subject area is an action that it can perform, or it can also be used to do custom queries to a certain endpoint on either a server or a different application. And finally, you have prompts, which is the way for you to pre-design some prompts, some communications for the AI agent so that the user wouldn't have to go in and create this very long prompt that we've seen all over the internet at this point, where you write out a 30-minute essay just to make it do one action, but you can actually provide a server where it already does that and then also inject data into it that you have on that server, so it has the full context. Now, this is the very short and brief version of it, but I think the easiest way to just think about it as a developer is always just to think of it as it's the LSP, the language server protocol, but this time it's for an AI instead. And that is very basic, very short coverage of what the model context protocol is. You can go a lot more deep into it, but Now, the challenge is then, how do we get MCP into CAP? And there are multiple approaches. And the approach you'll see today is one of the approaches that we went with. But the key goal of your MCP server when you integrate into CAP is just that it needs to structure that data into the expected format of the MCP. And one approach is, for example, to read all the metadata of your OData service and then have that be what the format should be out. The approach we've taken here today is a bit different from that. We've basically gone with an opt-in model instead. Another thing you have to keep in mind when you're integrating MCP into CAP is that you have to determine a transport type. Where is your server running, your CAP application running? Most of the time for us, our CAP applications, well, 99% of the time, our CAP applications will likely run in BGP. So we will need something that can communicate across the internet. Therefore, in this case here, HTTP transport is the way to go. But MCP does actually allow you to do multiple types of transport. Currently, the main ones they support are HTTP and then STDIO, which in this case, STDIO wouldn't really work for our approach, at least not simply. So with our transport type of HTTP and CAP, we just need to figure out what the middle point is between those two. And luckily for us, CAP is, at least the Node.js version, is running on Express underneath. So we have a way to then integrate it into the Express layer and then expose our MCP endpoints from there, but while still having it in the context of the CAP application. And that is basically the way we've gone ahead and done it. And I briefly mentioned just before an exposure plan, but it is very important to choose the correct exposure plan because you don't want to overdo what the AI has access to. And that's why we went with the approach that we wanted to have something that was loosely coupled, because that is the key to it. But we also wanted something that not only protected the data that you didn't want, and we did not want to overexpose. We did not want to make it hard for the developers either. So we just hadn't been back of our mind. We need to keep a good developer experience, and the way you do that with CAP to keep a good developer experience, where you don't have to write too much custom code that doesn't need maintenance, that is through annotations. So, in other words, annotations for this approach of implementing MCP is taking the keys to the kingdom, which is, annotations. And this is basically the approach that this MCP plugin uses to work with CAP. We annotated that we want MCP to expose something, be it either a tool or a pre-designed prompt, or in this case, also maybe wrapping an entity with smaller additional tools that has a lot of power. But what it was really important about the annotation part is that it gave us the power to do opt-in directly on what we already had exposed. So we're not exposing additional stuff we already have exposed to our function imports, our action imports, and our entities. We just now had to make an opt-in decision of which one of those endpoints would now also be AI enabled for communication. And the best part, if you don't have the annotation, well, we don't have access to the agent. The agent cannot access that endpoint anymore. Another key point of this is that we could actually then also reuse the authentication that was already there, meaning that if you went in and created an endpoint and set the restrictions on it that you needed a certain role, that would also then affect the end user using the AI agent, such that they don't, even though they are using the AI agent, they don't circumvent the restrictions that were already set. And it's a way for us as well to also keep it at the point where this is tools we know. These are the ways that we are used to working with CAP. So we don't have to teach people an entirely new way of implementing. We can actually go with the existing approach of annotating elements with what we want them to do. And most importantly, it gives us a unified API design. But I think that's enough background story for now. I actually want to show a little bit more about what I'm used to working with, and that is, of course, code. So we're quickly going to now jump into. Oh, there we go. We're now going to jump into the code a little bit and see how we can actually implement this. And what you see here, first of all, is that we just have a very simple cap application. It's the more or less the standard bookshop that you've probably seen 1,000 times by now. We have the books, we have the authors, the genres, and we have a couple of function action imports and also a bound function import. And what we want to do is we want to turn that application into something that the AI can do. And actually, just to give you kind of an idea of where we're going with this, let me actually go over to an AI agent and quickly ask about some information in there. So right now, I have a version of that application you just saw running up on BTP. And my AI agent here is actually connected to it. So I can actually go ahead and ask it, how many books do we have in the bookshop from the author Stephen King, as an example. And it will then automatically, because it knows that I said bookshop, which is what I've named this connection to the MCP server, that it can then go here and find it. And it first did a query to find the authors, because we've exposed authors as a tool in the deployed service. And it then also went, after it found out what the ID was of an author named Stephen King, it could then go in and then automatically query for the books and get the information that we wanted. And you can see we have a total of 79 Stephen King books in stock. Among them are 8 titles, and we have all the information here. So that is basically where we're at, or where we want to be. So how do we then turn this existing app application into what you just saw? The quick way is that first we need to go and install the cap MCP plugin. Once we've done that, we can then configure a few elements ahead of time in our CDS section. And for the sake of this demo, I've also included just that we want debugging log on MCP so you can see how it actually handles all this. Now, what we then do is we just add, kind of like we would with any other plugin or service requirement, we're going to add in this section here about MCP. And inside there, we're just going to give it some base information so that it has that for when it needs to integrate for it. And we're just going to give it a name. In this case, I'm going to call it My Bookshop. So that is the name that it will tell the AI agent who it is. So in this case, I'm telling it, I am My Bookshop. So whenever I say My Bookshop, it will automatically associate that with it. And then for the sake of just this demo here, I'm just going to not go too much into the authentication part. So I'm going to turn that off because we want to test this locally. And right now, that is the easiest way to do it. By default, whenever you have this installed, if you don't provide, for example, the name of My Bookshop, it will take the application's default name. And in case of the auth, it will always default to inherit, meaning that it will inherit whatever authentication plan is already on your cap application. Now, what we then want to do as the final step here is we want to add in our instructions. And the instructions is a key property that the AI agent receives whenever it connects to our application through MCP. And we just want to quickly tell it that it should use this server to query books and authors. That's what the goal is of this MCP server. Once we have that, we're pretty much ready to then go ahead and run it. just to see how it looks. And I forgot the commands. So there we go. That's the correct command. Now you can see it started up by saying it has received the event for bootstrapping the MCP client, is registered the health endpoint, which is a keep endpoint to check if your MCP server is actually running. And it's been running through the annotations, but as you can see, it says there's no annotations. It really locks out that we've actually done. And that's because we haven't gotten to that part yet. So if I now connect it to this MCP client or to this MCP server, it would actually just show it doesn't have any tools, it doesn't have any resources, and it doesn't have any prompts that we can utilize. So it's practically useless right now. But now we want to actually go ahead and add that in. So we're going to go to our cat service, cat service.cds file, and we want to add in our first element. The first thing we want to do is we want to say that our books are a resource. And we do that by using the keyword of MCP for the annotation. And that is an object that we can then use to then go in and give it first what is the name of this resource. In this case, it's books. We want to give it a description. The description is not for you as the developer. It is for the AI agent. So when you write these, think of it as you're writing to the AI agent and telling it about what your API is actually capable of. In this case here, because it's a resource, I know it's read-only, so I'll just tell it that this is book data list that will get out here. Then I have an option, because I need to tell it that it is a resource, but I can do it in multiple ways. I can tell it that it's a resource true, meaning that it's capable of doing all possible standard OData operations, meaning filtering, order by, select, skip, top. Now, if I wanted it to just only be able to do, for example, should only be able to do filtering, I can then add that in. Or let's say it should only be able to do order by, I can do that as well. If, for example, I leave out top, it would automatically default to just only showing the top 100 records to save on the performance of the application. So if you wanted to really have the true power, then you can do resource true. So now, if we save this, we've marked out that there's a resource available. And if we go down and check now in the log here, you can see it's parsing that annotation. And this is where we can then use another tool. Behind the scenes here, right before you got to see the IDE, I ran a command where I ran the MCP inspector tool. And I have that open over here on our another window. And in here, we have all this ready. So if we just connect to it, so now we're connected directly to our application. If we go back to the terminal here real quick, and we open it up, you can see it actually handle a request. It just opened a session. So that's the inspector that you just saw. And if we then list our static resources, we get nothing, because in this case here, we actually have parameters on it. But if we list the resource templates, which is the one that are actually coming in dynamic, we can then see we have here now a book data list, and we're telling by default that should query this as OData before style. And these are the filters, order bys, tops, and everything. And we can fill that out to now get the data. Now, this is only giving us the access to actually do this immediately, or to read this out only. It would actually be cooler if we could do a little bit more. And that's where we got the feature of then doing wrapping. So if we go back to the IDE and we go back into our service definition file, we can then add in an additional element. We can annotate the books entity a little bit further. So let's do that. What we're going to do is we're going to annotate catalog service books with mcp.wrap, meaning we're wrapping now the entity with additional tooling. We're saying this is a tool that or tools, multiple tools that we want to add in. And we then tell it we want it to be able to query meaning a list. We want it to be able to get specific elements, and we want it to create and update. And if we're really feeling frisky today, we can also go in and tell it that we can do deletions. Now, when we then add that in, and now I forgot to disconnect before I restart the server, so now the inspector is going to have a bit of a fit. But let's do a quick refresh here, just to make sure we start up a new session. Open up session, go to tools, we list them out, and you can now see we have the description of a model, and the tool is not coming from the rep, so I forgot to add something in. Let's see what that is, because we'll actually get that told to us pretty straightforward here. You see we get told that we have these functionality when it connects. So it didn't get in our cat service. So let's see what that's about. We forgot to enable that feature. So let's go ahead and actually do that. We're going to go to the MCP section of our package.json. We're just going to quickly tell it that we are actually allowed to do this. Wrap entities to action. And we go back to the cat service file here. Oh. Now it should be there. If we check the annotations, you can see it's actually found all the wrap modes. It found the hint as well. Now we're off to a little bit of a better start. And then let's actually go back over to our inspector tool. And in the inspector tool, we just need to reconnect. We're going to list out the tools, and there we have them. So now we're actually able to do direct querying. Let's say, for example, we have a tool now for getting the books by the ID. So if there's multiple IDs, we of course need to fill that in. I can then get book with an ID of 2. That's apparently Harry Potter in the Chamber of Secrets. I can also go in and query and fill out the different information. I'm just going to do a query all here and see what we get. And we get all of the books we have in the system. So now we've enabled the option of doing all this right up ahead, right in front of us. And we can even go in and create additional. And that's now available for the AI agent to perform. Now, of course, this is a lot of power to open up for the AI. So we could have just limited it and said, well, you're only allowed to read it, but you can do it with these methods instead of actually being a resource. It depends on your end goal here. Next part is, of course, now we've covered the tooling, how to do a resource and how to do a wrapping of a resource so it also becomes a tool. But we also want to then go in and actually do a get book recommendation. And the way you do that, we start out with the same keyword. And we then go in and say, this is going to be our tool. True. Actually, let's start out with the name. We're going to call it get book recommendation. And description for that one is going to be that it gets a random book recommendation, because that's what I've implemented it to do. And there we go. Now we have exposed get book recommendation as well. So if we once again check our implementation of the MCP right over here, connect, go to our tool section and check it out. And we find get book recommendation here, and we can even test it. And we've just been recommended to read the Testaments by Margaret Atwood. So maybe I should go and read that at some point. So the tool annotation here can be used for any type of function or action import by default. It cannot be used on the entities. If you want to make entities into toolings, then you need to use the wrapper. And of course, you cannot only just do it on, unbound function and actions. It is also possible to do directly on our bound elements as well. So for example, if I wanted to go in and add get stock, it's the same approach, MCP, name, get stock, gets the stock of a book, a certain book. And this implementation, as you see, is not fully complete. But we can then go in because we need a neat or actually, it is fully complete. But yeah, now we have it. We can also get stock. So if we once again go back over to our books and actually, our bookshop inspector here, we're going to inspect it. And now we should see get stock is actually here. And you can see because it's bound, it automatically asks us to get that of a book. And apparently I forgot to implement a handler for this. So we also get the errors directly from the catch service as well. So, but yeah, there we go. It automatically finds out the bound entities. So whatever the action and function import is bound to, it will automatically go ahead and find that key and then ask for it as part of the parameters to the AI agent. And if you also have parameters on your bound action import or function import, it would also include those. So now we've covered the tools, the resources, and the wrapping functionality of the plugin. I quickly want to just do the final bit that we also discussed in start. And that is, of course, that we can annotate our entire service with prompts, predefined prompts, where we can make use of the data that we have, and we can actually also make use of wanting it to give it a predefined prompt that the AI agent can then use for it. This is a very simple one, but you could, in theory, have written an entire essay here ready for it to be to use. For example, if you have like a predefined workflow that an AI agent should be doing, well, then this is the really good place of doing it. But just to quickly show how it works, we just add it in here with the MCP prompts, and that is on the service itself that you annotate that. And then in that array, you just add all the prompts that you have in this structure here. And if we then move back over to the inspector just to check our implementation, you can then actually go in and see on the prompts, that was right there, that we now have an available predefined prompt that the AI agent can use. And if we give that to it, it'll get that response back. So let's say it's a book idea 2, then it'll send back the message of actions that we define that the AI agent should do. That is basically how the AI agent how the MCP plugin work. And it is just a matter of going through it and say, what do I want to expose? And as you saw, we didn't expose submit order. So therefore we do not have access to submitting orders through the AI agent, through the MCP protocol, because we have not actually made that available to it. And we had the option also of going in and saying we only want you to have tooling for querying and getting the books in our application. We don't want you to create or update or delete it. We just want this. So actually, we should probably also update this hint, otherwise it's going to get confused. But we now have the option of limiting the scope and giving it only exactly what it needs to help the AI agent going forward. Yeah. So hopefully you'll see the big picture here and see that this is something that can really help a lot. One of the ways that I've already seen it being used a lot is by making AI agents interact with existing services on BTP, for example, the workflow services, by way of actually querying in through the AI agent directly to ask, hey, do I have any workflows pending my approval? Well, then it will go to the CAP service that acts as a middle layer where we've annotated this and actually ask for that, and it would come back in natural speech to whoever queried it. And it doesn't stop there. It is also a way for us to annotate our models to quickly go out as a developer and figure out what it can do, because we can then query the CAP application and find out what is actually possible on it. Of course, only what we've annotated that it can do, but still, it will help a lot. So yeah. Now we're done diving for now. I highly encourage you to go and also dive into the source if you want, because this is an open source plugin. But just to wrap it up, it's really, with this plugin, it's only your imagination and probably also compliance that sets the boundaries for what you can do with it. And it is just a quick and easy way to start having AI interactivity with your existing CAP applications out there. And playing around with it as a developer is also extremely fun, because it can really make interesting new ways of handling existing issues. And I hope that you come out of this with an indication of how AI or how annotations can be used to power your CAP applications, and also how AI context enablement, it shouldn't be hard. It should be easy for you to go out and do. You shouldn't have to go out and start training your models and working on very complex custom integrations. It really should just be as simple as writing an annotation. And that is the superpower of CAP. That is the annotations. So I hope you get that. And as well, I also hope that you see how MCP can help your CAP applications achieve that next level by providing an additional API besides the existing OData and GraphQL and other options we already have. So you can now really support everything through CAP. And hopefully it has also shown you the power of MCP and the power of CAP's plugin architecture, because it truly is extremely cool how you can create something like this that is just plug and play directly into it. And then I hope you also see what the power of open source is here. But that's all that I have for now. So I hope you've enjoyed this little presentation, and feel free to reach out if you have any questions. Yeah, thanks for having me.